resistors, but that's pretty basic stuff. All right, now some things you guys know. You probably are used to that picture of a resistor, okay? You've dealt with that lots of times in the lab, and I would hope that most of you guys are actually able to read that resistor. All right, I'll talk about how to read a capacitor here as we go. All right, but that's something we'll get to. All right, if you don't know how to read a resistor, you should probably try to. If you go through that drawer in that lab upstairs, remember, you guys are going to find out that, you know, everybody's come along and just treated that thing like crap, and you're going to think you're getting a 1 kilo ohm resistor, and you're going to get a 1 ohm resistor, and it's going to blow up in your face. So just make sure, you know, you actually read that stuff. All right, here's two types of resistors. Now you can probably get a good sense of this one. It says 10W, 10 watts. Okay, so this thing's rated to carry some power. Now these are the ones that you guys typically use. All right, now this one is not rated to carry that kind of power. All right, so typically on a resistor, there's some key things we got to keep in mind, and they really do affect designs, especially if you need a precision design. All right, so if you're in the aerospace industry or the military, or you're designing something you really need some precision, you really have to be careful about what components you pick. You may think picking a resistor is simple, but it may not be. All right, so this resistor here, when it has, and you can't see that too well, when it has this gold band on it right there, it means it's got 5% tolerance. All right, so 5% tolerance, what's that mean? Well, if this is let's say, if I look at the colors on this one, I think this is a 68K resistor. All right, if it's 68K and it's got that 5% tolerance, that means it's 68K plus or minus 5%. All right, so it's not going to be exactly 58K. That may not be good if I'm looking at a precision application. If that's the case, I might want something a little bit better. All right, some of the other things, this guy's rated for 1/4 of a watt. All right, which means that it can pass 0.25 watts. Okay. If I need to pass 10 watts, I need something like this. Now, what's the difference? Well, these are made with different materials. Okay. Some other things on here. This thing is got temperature variations to it. Okay, so if the temperature varies from 0 degrees C up to 100 degrees C, this temperature might change. All right, if you're talking about an aerospace application or a military application, that may not be good enough. That may throw off the gain of some circuit, all right, and affect some things. Okay. Now, in general, these resistors as well, these ones here, are meant for 250 volts maximum applied. Okay. If I start to apply voltage to this thing, typically there's a voltage coefficient. So if I apply a lot of voltage, the resistance is going to change. That may be something that matters. And there's all sorts of things that will affect this. Okay. Once I solder this into a circuit, it usually changes its resistance permanently. Okay, not by a large amount, okay, by a couple of percent. All right. Also, if I load cycle, if I apply a high voltage to it and then turn it off, high voltage to it and turn it off, and that's the kind of thing that might happen. That also will probably permanently change it. Vibrations, high vibrations can change the resistance, humidity, all sorts of different things. Okay, that's something to kind of keep in mind. Now, there's the types of materials. This is what's called a carbon composition resistor. Different materials have different behaviors. Usually when you need precision, you get one of these types right here. This is a 1% resistor. Okay, the blue ones are usually 1%. And it's metal film. This one's carbon film, okay, or carbon composition. This one here is metal film. Metal films are usually quite a bit better in terms of how they behave. Okay, 1%, and then they're more robust against variations in applied voltage and temperature and humidity and things of that nature. When you need power, you go to something like this. And this is high tolerance resistor. But you can get a low tolerance, a really precise power resistor if needed. Okay, and oftentimes you do. Power resistors, a lot of times you need to use them to measure currents and things like that, and you need to be very, very precise. All right, resistors are pretty boring though, and so we're not going to say too much more about those. Capacitors and inductors are really where things become a little bit more sort of intriguing to some extent. Okay, now capacitors, same thing. They are, and this is where it really gets into stuff that's going to affect you in the lab. Okay, so if you've been zoned out, you're probably going to start zoning back in. All right, so with a capacitor, again, they vary with temperature. They have a tolerance. They have all that sort of stuff. But they also have power limits, and they also have voltage limits. So there's a maximum voltage that can be applied to a capacitor. There's a maximum power that can flow through it. Okay, and that might be a little bit strange because capacitors supposedly don't dissipate power, but they do. All right, a real capacitor does, and that's something we got to talk about a little bit. All right, so let's let's get, the basic picture. So when you're in Adams' class and he's talking about capacitors, all right, he's probably going to draw you a picture that looks something like this. You're going to have a plate, basically 2 plates, all right, and there's going to be positive charges here and negative charges down here. Okay, and in between that plate is going to be some sort of material called dielectric with some permittivity epsilon. And the capacitance should be, epsilon A over whatever this length is here. We'll call that length D. Alright? So it's epsilon A over D, okay, where D is the distance between the plates. Alright, that's our basic formula for capacitance. Most capacitors don't quite look like that. Okay? The basic ones that you guys see that do kind of look like that is the ceramic disc capacitor. Okay? Where these 2 leads go in and they actually do attach to some kind of a disc. And then there's some sort of material between them. So I call that a ceramic capacitor. So guess what? The dielectric in between there is going to be ceramic. Okay, so let me go back here to sort of a cutaway picture of it.